Welcome. Here we have a children's toy with a ball attached with two strings and a large pole. And the pole is allowed to rotate a little bit, and this causes the ball to go into circular motion. So we want to think about what's going on with this, and we want to find tension in our upper and lower strings. So we're given information of the mass is 100 grams. We're given information that omega is 15 radians per second. And we're given this distance, capital R, is 10 centimeters. So we want to find the tensions, Tu and TL. Our first steps could be getting another sketch going of this, so we could do a top-down or circular view. But there's not too much going on here. It is kind of nice to have the sketch. What's really important is which of these views we want to draw this free body diagram in, and this view that we've already drawn it in is a great chance to do that. So we'll draw our ball like this, and we will have a couple of forces. So our ball is in contact with this upper string, this lower string, and that's it for contact. And then it has a non-contact force from gravity. So we will draw the tension up, tension lower, and the force from gravity. Well, in this example, it's probably best to think of this in the R direction and the Z direction. And so then as we do this, then our free body diagram, again, this will be the R direction, this will be the Z direction. So we can write our Newton's second law. So our Newton's second law, we're just going to do the vector form, just writing all of the individual forces, tension upper, tension lower, force of gravity divided by the mass. And then what's nice about circular motion is that we always decompose into the same system, and we always have the same acceleration constraints. So we always have a sub r, and that's always equal to r omega squared. We always have a sub t, and that's equal to r alpha. And we also have a sub z, that's also equal to a 0. And then what we need to do is we need to figure out which direction these things are in. So a sub r, we have tu in the radial direction, and it's negative. Oh, this is negative as well. And then we have TL in the r direction, and that's negative. And that's the only force in the r direction, so we divide by the mass. In the t direction, we don't have any forces in the tangential direction, That's why we drew this thing, why it wasn't all that important. And in the z direction, we have tu in the z direction, and then minus TL in the z direction, and minus gravity over the mass. So we've chosen some easy examples in this case. So when we do a little bit of math, we get that TUR is equal to TU times sine of 45 degrees. TUZ is TU cosine of 45 degrees. And they're the same. And LR and TLZ are going to be the same. TL sine of 45, TL cosine of 45 degrees. And in fact, if we remember, sine of 45 degrees equals cosine of 45 degrees is equal to 1 over square root of 2. So we can take some of these things and better understand them by writing them out a little bit nicer. So we have negative r omega squared is equal to negative tu over square root of 2 minus TL over square root of 2 all over the mass. So we can first off cancel the minus signs, and then we can multiply both sides by square root of 2 and m. And so we get over on this side, square root of 2 m r omega squared is equal to tu plus TL. We also have in the z direction tu minus TL, both these over square root of 2, minus mg is equal to 0. So with a little bit of math, we can get for this one that tu is equal to TL plus square root of 2 mg. And then we can then sub this in to this equation. So we have this square root of 2 m r omega squared. Every time we see tu, we can replace it with this. So we have TL plus square root of 2 mg plus TL. And we can do a little bit of moving things around. So I can move this square root of 2 over, and I can combine these two. And so I get 2TL equals square root of 2m r omega squared minus g. And then dividing by 2, we get TL is m r omega squared minus g over the square root of 2. So we can plug in 100 grams. 100 grams, right, more usefully is 0.1 kilograms. We can plug in 15 radians per second. We can plug in 10 centimeters. When we do all of this, we get that our TL is 0.9 newtons. And then for this TU then, we get 0.9 newtons plus square root of 2 mg. And this would give us 2.3 newtons. So this is how we solve problems in this way, right? We get a sketch, we get all of our stuff in our organized step, we get a free body diagram still in the sketch step, writing down our equations in third law until we get to our two equations, two unknowns, and go down and solve. Thank you.